Lesson 9.2, Significance Tests and Decision Making. To refresh, there are two types of conclusions we can make when conducting a significance test. The first is when the p-value is small, or less than 5%. In this situation, we saw an event that we would consider unlikely to occur by chance, and because of that, we're going to reject the null hypothesis. That leaves us with only the alternative hypothesis, meaning that we have convincing evidence that that alternative hypothesis is true. The other conclusion we can make is when the p-value is not small. In this situation, the result that we observed in our sample is at least somewhat likely to occur by chance. And for this situation, we would fail to reject the null hypothesis, meaning that we don't have convincing evidence that the alternative hypothesis is true. Now, why do we use that 5% cutoff? Why is it not 10% or 1%, etc.? In truth, that 5% is somewhat arbitrary. It corresponds to an event that would occur in only about 1 out of every 20 trials. That's our standard for what we consider unusual or unlikely, but sometimes we want to change that to make our standard for what we consider unlikely a little bit harder to meet. So for example, we could set or change this 5% to 1%. All right, we would need to see an event that would occur only 1 out of 100 times, or we make it a little less likely and set it as 10%. This cutoff that we're choosing for the problem has a name. It's called the significance level, and it's denoted by this symbol, which is alpha. Right? It's also referred to as the alpha level. So the significance level, or the alpha level, is the cutoff for what we consider an unlikely event, for something that would be unlikely to occur by chance alone. When we have a p-value that's smaller than that alpha level, we have been using 5%. All right, and when the p-value is less than 5%, we would reject the null hypothesis. And this hypothesis test would be statistically significant at the alpha equals 5% level, 0.05. Again, we could change that. If we change it to 1%, now our p-value has to be less than 1% to reject the null hypothesis. Now, in a lot of situations, we won't be given an alpha level, and in that situation, we're just going to use the 5% because that's the standard value. However, in other problems, it'll say we'll set the alpha at 1%, 10%, etc. And in those situations, when our p-value is less than the alpha level, that's when we reject the null hypothesis and conclude that there is convincing evidence in support of the alternative. And if the p-value is above that alpha level, we fail to reject and find that there's not convincing evidence for the alternative hypothesis. So let's say we conducted a hypothesis test with a null hypothesis being that the mean battery life of all these AAA batteries is equal to 30 hours. The alternative is that it's greater than 30 hours. When we run the test, we get a p-value of 0.0729. What conclusion would we make at a 1% alpha level? Well, since this p-value is above that alpha level, it's not small enough for us to reject the null hypothesis. So because that p-value of 0.0729 is greater than the alpha level of 1%, we're going to fail to reject the null hypothesis. And because we fail to reject the null hypothesis, we do not have convincing evidence that the company's deluxe AAA batteries last longer than 30 hours on average. Now, when we conduct a hypothesis test, occasionally we're going to make the wrong decision, and it's going to happen just by chance. Rare events do happen, and when they do happen, we're going to assume that they occurred because that null hypothesis is false, but that actually might not be the case. So when we witness a rare event in one of our hypothesis tests, we'll probably make the wrong decision and make either a type 1 or type 2 error. Now, these are a bit difficult to keep track of at first, but the more more of these problems you do, the clearer it gets. So a type 1 error occurs when we reject the null hypothesis that's actually true. When we reject the null hypothesis, we find convincing evidence that the alternative is true, but because this is an error, the alternative isn't actually true. All right? The null hypothesis is true, but we rejected it. That's why it's an error. A type 2 error is the reverse of that. It's when we have a null hypothesis that's actually false, but we fail to reject it. So in those situations, we don't have convincing evidence that the alternative is true, but in actuality, it is true. So let's take a closer look at this using the hypotheses in that last example. So our null hypothesis here is that the mean battery life for all these AAA batteries is 30 hours. The alternative is that it's greater than that. If we make a type 1 error, we're going to reject the null hypothesis and conclude that the mean battery life is greater than 30. Maybe we ended up with a p-value that was just under our alpha level of 5%. Since this is smaller than 5%, we would reject that null hypothesis. Since it's an error, this is a type 1 error, we're rejecting the fact that the mean battery life is 30 hours, when in actuality, that's true, and we're rejecting it. A type 2 error is the reverse of that. So in this case, we're going to fail to reject that null hypothesis. Okay, maybe in this case, we get a p-value that's just over our alpha level. Say it's 0.073. Okay, we fail to reject that null hypothesis. That means we don't have convincing evidence that the alternative is true. But again, this is an error. Their true mean lifetime really is greater than 30 hours. We're just not reaching that conclusion. It's only possible to make one error type at a time, and that depends on which conclusion we made. So on that earlier example, we had that p-value of 0.0729 and compared it to an alpha level of 1%. We failed to reject the null hypothesis because the p-value is over that alpha level. And when we fail to reject the null hypothesis, we can only make a type 2 error. All right, a type 1 is when we reject the null hypothesis. A type 2 is when we fail to reject the null hypothesis. Some questions are going to ask which error type is more serious, and really it depends on the situation. So looking at that battery problem, a type 1 error, when we reject the null hypothesis that the mean battery life is 30 and conclude that it's greater than 30. All right, now remember, this is actually a mistake. So we're rejecting that, we're concluding it's greater, in which case they're going to pour a lot of money into producing batteries that they think last longer than their old ones, when in reality they don't. Okay, and they could have saved a lot of money just using those old batteries, which have that same average. In a type 2 error, we fail to reject that null hypothesis, meaning we have enough evidence that the mean is greater than 30. So we would conclude that these new batteries are not more effective. We would continue to use those old batteries, all right? And in reality, the new batteries are better. So depending on what the company's goals are, would really dictate which of these is more serious. When you're asked a question like this, you want to pick one and justify it. All right, let's say we pick type 1. We would say type 1 is more serious because they're spending all of this money producing these new batteries which aren't actually better. Or we would say type 2 is more serious because in this situation, they're not putting money into a new improved battery that actually is better than the ones that they're using.